Welcome back. So I had delicious sandwiches and cold drinks, so I hope you all must have also had something to eat. It's high time. Lunch once leke mat baith jayega, and please don't sleep, because these particular problems that we are going to discuss are also very important. So we will join again to that particular offside slider and crank mechanism example that we were discussing. We will look at it again once again. So this, we have the figure that is being animated, and this is a crank that is rotating about this axis, and this is the connecting rod, and this is the slider. So this is an example of application of the offside slider and crank mechanism that we discussed before the break. Okay, now what? 4-bar chain mechanism. So now we have discussed two types of slider crank mechanism, that is simple slider crank mechanism and offset slider crank mechanism. So now what next? We are going to discuss 4-bar chain mechanism. Now what is a 4-bar chain mechanism? A few points we should know. A 4-bar chain mechanism has 4 fixed links. 4 links that are there. There are 2 rods that will be rotating, or there will be one connecting rod, there will be 1 fixed link, and 2 cranks. That will be the kind of things. Now 2 cranks. Now one will be driven and one will be driving. Just as an engine, the engine is driving and the passenger coaches are being driven. So here also the same thing. There will be 2 cranks. One will be the driver, which is getting power from an external source, and the driven, which is moving because it is connected to the driving wheel through the connecting rod. Now there are basically 4 types of these mechanisms, out of which we will be discussing one today, but we should know what are the 3 types of mechanism. I'll show you the videos of the particular mechanisms and how they work. Okay, the first is both the cranks are rotating. In this, both cranks are rotating either clockwise, anti-clockwise. One is rotating clockwise, other is rotating clockwise, or vice versa. The next one is one crank is oscillating and one crank is rotating. One crank rotates through 360 degrees. The other crank has extreme points, say A to B or say C to D. It rotates, it oscillates between C to D, D to C, then C to D again and again. So that is the type of mechanism that is being followed. Both cranks oscillating. Now both cranks oscillating, in which we have 2 endpoints of both the cranks that oscillate between those particular 2 endpoints and do not complete a perfect circle. So now let's see, to make it more clear, the first thing. Okay, yeah, here we have it. 4-bar chain mechanism. The first is both cranks are rotating. On the left hand side, you see the figure in which the greens donate the rotation, the path of the rotation of the crank wheel, and the Q is the one of the cranks. This is the static link. Then again this is the movable link, and this is L. So let's play the video again. Here we have, this is the connecting rod. Both the reds are shown. These are what? These are the cranks which are rotating. Both are rotating anti-clockwise, and this is the fixed link. So here we have 1, 2, 3 and 4. These are, let's see it again once again. Where is my video? Yeah, 1, 2, 3 and 4. These are 4 links or 4 connections of 4-bar chain mechanism as required. Okay, let's see the next one. Here we have one rotating crank and one oscillating crank. Now let's see this. On the left hand side, this is the crank which is rotating on this particular path, and it is being hinged here, so it rotates about this particular point. This particular link is static. Restart the video. This particular is static, and this is the crank which is oscillating about these end points. So these are the extreme points through which this particular crank oscillates, and this is the connecting rod. And now let's see the video of animation. Now blue is the crank which is being rotating in a circle, as you can see. Red is oscillating about these 2 extreme points, and as you can see, this is the connecting rod and again the static link. One more thing that needs to be mentioned in the video. Okay, 1 link, 2 link, 3 link and 4 link. So it becomes a 4-bar chain mechanism. Let's see the video and then move on to the next slide. Okay, we have the next slide in which these both the cranks L and P, these are both oscillating cranks, and this is the static link, this is the connecting rod. For this particular link, this is the oscillation zone. For this particular link, this is the oscillation zone. These both are hinged, so these are the centers through which they oscillate. Now let's look at the video. Yeah, now there are two cranks, both in red. The connecting rod is in green. Now for this particular crank, the extreme points are from this point up till this point, and for this particular crank, the oscillation points are from this particular end up till this particular end, and then again it follows the same path. Okay, now let's move on to the next slide. Now we will see and discuss an example. For that, the videos are different, and when we draw a line figure, it is a different in understanding. Not basically they are different, but they are just different in understanding. So now let's just see how a line diagram of this particular thing in motion looks like. So let's see this animated. Oh sorry, first I'll show you an application of a 4-bar link mechanism. Now this is a very interesting application. It is not general, it is used by mathematicians, it is used in industries, it is used in a lot of places. As you see, this particular scale is a geometric scale. So this is 1 inch or say 1 centimeter or whatever you want to mark through X, and this on blue is a logarithmic scale that is being used for different scientific calculations. So now if I want to measure the logarithmic scale by using this particular height, I'll have a particular calibration of these particular links. Now there are, first we'll check if it is a 4-bar mechanism or no. This is first link, this is second link, this is third link, and this is fourth link. So now I'll check whether I have my two cranks. Let's see. First I'll check for red. Yes, this is a oscillating crank which oscillates from 1 till 10 and from 10 to 1. Now again for the another, if I let's just find another crank. Okay, so this is the link, so this is my other crank which is going from 0 up till 2.25. Here we go 2.25, and then it comes back to 0. Okay, the next thing that I want to find is my connecting rod. So I see that these are the both oscillating links, or say oscillating cranks. The only thing that is connecting between these two is this particular green link. So this green link becomes the connecting rod, isn't it? Yeah. So I need not power these both the links. I just have to give power to one, or I just need to rotate one, and according to the calibration, the other link will rotate all by itself. It depends on the length of these particular links, it depends on the length of the connecting rod, that what calibration we are going to use. So this is a very basic application, or say not a very basic, it is a very complex application, but very simple application. Complex and simple. A complex mechanism made simple. If I need to calculate from I need to calculate normal scale to log, then I need to do a lot of calculations. But if I calculate it once, I can get the links ratio, and then I can make a 4-bar chain mechanism, and I can make a scale. Then using that particular scale, if I want 1 centimeter on logarithmic scale, I can get it through this particular mechanism without having to go through a lot of paperwork for doing it. Okay, so let's skip this and go to the problem directly. Okay, now we shall first read the problem, and then we shall see the animated line figure of that particular problem for which is being made for this particular problem only. Now let's see. Read the question carefully. I say it again and again, and I will read the question carefully. Two equal cranks AB and CD. I have two equal cranks AB and CD. What does that mean? AB and CD are two cranks. That is my first fact. Second fact is that length of AB is equal to length of CD. Okay, is connected by link BD. Two cranks AB and CD connected by link BD. So there are two cranks AB and CD which are connected by BD. So BD is my connecting rod. Now what they say, rotate in opposite directions. again clockwise and anti-clockwise, it is not mentioned which crank is rotating clockwise and which is rotating anti-clockwise. So it's up to me to decide that which crank I want to rotate clockwise and which crank I want to rotate anti-clockwise. So I will take the driven crank, I will plot it clockwise or anti-clockwise as I wish, and accordingly I will plot it for the driving crank. Oh sorry, the driving I'll decide and then I'll plot it for the driven crank. Okay, let's read further. Draw the locus of a point P on BD and of Q along extension of the rod B for one revolution of B. Now P is on BD and Q is on the extension of the rod. So that we will see in the question that how we are going to plot this particular thing. P is on BD, that is the link BD. It is the same old procedure that we did in the last two questions. This point Q is along the extension of this particular BD beyond B. So we start from it's like we'll start from Ahmedabad, we'll go till Surat. So there are 3 points: Ahmedabad, Vadodara and Surat. So my Nadiyad is my point, say Ahmedabad is my point B, Vadodara is my point D. So my Nadiyad lies between B and D, so that is my point P. Now if I want to go to Surat, that is beyond Baroda. So what is that? Ahmedabad to Baroda is my connecting rod, and beyond that is my Surat, that is my point Q. So we have to plot the point of that particular point also along with the point Nadiyad, that is between the connecting rod, say as it is between Ahmedabad and Baroda. Okay, for one revolution of AB. So as AB rotates one time, the whole rotation 360 degrees, we have to plot the locus of both these particular points. What information is given to me? AB is equal to CD is equal to 450 mm. AB is equal to CD. What does this say? See, from the figure we have made out AB is a crank. Now CD is AB and CD both are cranks which are equal to 450 mm. As we read, both cranks are equal. So AB is equal to CD is equal to 450 mm. Now the next thing is AC is equal to BD is equal to 1500 mm. BD is the connecting rod, but what is AC? AC is the distance between the points center of both the cranks. That is, A is the center and A is the center and C is the center. AB crank and CD crank. So A is the center and C is the center. So the center distance, the distance between both the centers, AC is equal to 1500 mm, which is equal to the connecting rod, which is BD, and both dimensions are 1500 mm. PD, that is the distance of P, the locus, for point P I have to plot the locus. So how far and where is that point? That point is on the connecting rod BD, and it is at a distance of 300 mm from D towards B. And BQ, so we know that it is beyond B on the extension of the rod. So what we will do is the line BD is extended towards B, beyond B, and 300 mm beyond B we have a point which is by the name of Q. So now let us look at the animated figure. Okay, on the left hand side is the driving crank, on the right hand side it is the driven crank. In the question it says that one link is rotating clockwise and both are rotating opposite directions. So in this particular figure, the driving crank is rotating clockwise, whereas the driven crank is being rotated anti-clockwise. So the figure is fulfilled. Now this is, we'll say if it is a 4-bar mechanism or no, one link, two link, third link and fourth link. This is my crank which is being driven, this is my crank which is driving, this is a connecting rod, and this is the static link which is not moving at all, and keeping both the end points of and the centers of driven and driving crank together. Understood? Let us look at one more rotation and then we will move forward. Okay, now let's go up to the particular first step. What we do? We are going to follow the same rules that we did. We will draw the center line first. Then the next step, take any point A on the reference line. First of all, we are going to take a point A on the reference line, and we are going to point 8, and that is a driven crank. So we are going to take a point, say point A, as you can see on the left hand side of the screen besides the video. Now with center equal to A, now what we want to do, we want to plot the crank circle. After taking the point, we always put the crank circle. So with radius equal to my crank, that is my AB, is equal to 450 mm. So I'll take the radius on my compass, then I'll put the pointed end at A, and I will draw a circle. Now this is the crank circle of the driven wheel. Oh, sorry, driving wheel. I'm sorry. Now I'll draw the crank AB. Let's move. What is the next thing that I want to do? See, now I have two things that I can do. I have my distance between the two centers, and I have the distance between the connecting rod. So which distance am I going to take for my next step? So I need to think, do I have the perfect reference line for plotting any of those points? Let's see. For connecting rod, if I want to cut an arc, so I'll take my radius equal to 1500 mm first of all, because AC and BD both are 1500 mm. If I want to mark the center, or if I want to mark the connecting rod, I have to have radius equal to 1500 mm. Now first I'll put it on B. Do I have the particular crank circle on which the position of the crank will be there? No. Now I'll put it on A. Now the distance 1500 mm from A will be the center of the other crank that is being driven, will be also on the same reference line. So I have that particular reference line on which I can cut an arc. So what I will do, my next step, radius equal to 1500 mm and center as A, I will cut an arc and name it as C, as you can see just below the video. And this is point C, through which the other crank, about this particular point just beneath the video, you can see this just beneath the video, sorry, the video is gone. So this particular C is the point through which the other crank will be rotated, that is the driven crank. Okay, now let's see. I will connect AC, that is my the static link. The next step, it falls down and say the radius as again 450 mm, that is my BC, my DC.